All right, so we're going to do our factoring review for our exam. Now listen, y'all listen to me. Ready? The exam is going to be heavy factoring. Lots of factoring on the exam. We've spent a lot of time for it. It is the key skill to be successful in your upper level math courses. Algebra 2 is lots and lots of factoring. Trig, pre-cal, calculus involves lots of factoring, and the factoring gets more complicated, so your basic skills in factoring, which is what we've learned here in Algebra 1, are going to be all that more important. Now, how did we determine what method we would use to factor? When you look at an expression and the directions say to factor, how do we determine what method we're going to use? By how many terms there are, right? So if there's 2 terms, we use certain techniques. If there's 3 terms, we use other techniques. If there's 4 terms or more terms, we use still other techniques. So our factoring methods depend on the number of terms that we use. All right, so let's go over that real quickly, and then we'll just look at some examples and kind of see what's up. All right, 2 terms. What methods do we use to factor 2 terms? First thing we look at is we're going to see if there is a greatest common factor. Always. Okay? If we're going to factor things completely, we need to go in this order too. And there's ways that you can factor doing the GCF later, but it makes sense to always do it first. All right? Then what do we look for if we have 2 terms? We look for a difference of squares. That's correct. Difference of squares will always factor as conjugate pairs. So difference of squares. Now, we're not covering this in Algebra 2, in Algebra 1, but in Algebra 2 you'll learn how to factor cubes. And that's the third thing that you look for if you're factoring 2 terms or more. Or just, excuse me, if you're factoring 2 terms, it can be GCF, difference of squares, or cubes. Okay? What about 3 terms? First thing we look for is GCF. Yes, we want to find a GCF. Again, it's not something that you have to do first, but it makes your factoring easier to take out a GCF. And it also kind of ensures that you get the expression factored completely. Then what do we do? What do we call it? What do we call this technique? We're unfoiling it, right? We unfoil it. We called it trial and error. All right, so we pick terms or factors, and then we go from there. And that's it for 3 terms. Okay, you can take out a GCF, and then you can do the good old-fashioned trial and error factoring. We're going to try to bust quadratic expressions up into the product of 2 binomials by busting up the middle term. All right, and then the third category of factoring that we looked at was 4 or more terms. 4 or more terms. What are we going to do first? We're going to always look for a GCF first. And then we will do what? No, not trial and error for 4 or more terms.
Don't we have to break them up?
You break them up into what? Pairs or groups. Grouping. Factor by grouping. It's not necessarily going to be pairs. It'll be, if 4 terms, it could be pairs. There's a special kind of grouping that, again, this is an Algebra 2 topic that you'll look at. We're not doing it in Algebra 1. There's a special kind of grouping called compound squares. Compound squares is a type of grouping. Normally when we group, we're going to group 2 terms and 2 terms. Sometimes when you group compound squares, you might group 3 terms and 3 terms, or 3 terms and 1 term by itself. We didn't do that, but I'm kind of inclined to show you a compound squares. Would y'all like to see a compound squares? So you can kind of see what it looks like. A compound squares problem would look like this: x squared plus 6x plus 9 minus y squared. Okay, that's 4 terms. Would we be able to factor it by grouping the way we would want to factor it by grouping? No, because the second 2 terms don't have anything in common. The first 2 terms do. So what you do on this one is you group this one separate from that. Okay. Can we factor x squared plus 6x plus 9? What does it factor as? X plus 3 times x plus 3, which I could write as x plus 3 squared minus y squared. Now I have a difference of 2 squares. So I could factor this as x plus 3 plus y times x plus 3 minus y. Okay. That's compound squares. Again, that's not going to be on the exam, but you'll see it in Algebra 2. And it's not that difficult. You just kind of have to know that that's the next thing that you look for when you're factoring. Okay, so this factoring checklist that we've looked at, and we've covered this now several times through the year, is going to be extremely important for us. 2 terms, you look for a GCF, difference of squares. 3 terms, you look for GCF, then trial and error. You want to unfoil it. 4 or more terms, you look for a GCF, and then you factor by grouping. Okay, so let's look at some examples of these. You ready? The directions for all these problems is factor completely. And to factor completely, we're going to need to use that factoring checklist based on the number of terms that we have. All right, so let's dive right in. Example 1. 2x squared plus 22x plus 48. What am I looking at? 3 terms, right? How do we factor 3 terms? GCF, and then we're going to see if we can unfoil it, right? 2x squared plus 22x plus 48. Do we have a GCF? Yes. The GCF is 2. So that will factor as 2 times what? X squared plus 11x plus 24 is correct. Now, can the trinomial that's left over there, can it be factored further? Can we bust up that middle term? Are there factors of 24 that add up to be 11? 8 and 3. So this will factor as x times x gives us x squared. Positive 8 times positive 3 gives us 24, and 8x plus 3x is 11x. So there's my complete factorization of that polynomial. Okay? We've done lots and lots and lots of that. Now, could you factor this without taking out the GCF? Sure. What's the process for factoring this without a GCF, without taking out the GCF? 2 times 48 is 96. Factors of 96 that add up to be 22 are 6 and 16. Right. 2x and x. These have to be 6x plus 16x. So I can multiply this by 3, and I can multiply this by 16, right? Or I could multiply 2x times 8, and this times 6. Why are there 2 ways this one will work? Because we didn't take out the GCF, right? I can still take a GCF out of this. That's 2 times x plus 3 times x plus 8. Right? And if I factored it as, what did we start off with? 2 times, what was this? 3 over here, 16 here. 16 and 3. Then I would take the 2 out of this and be left with 2 times x plus 8. Alright. So it's easier to take out the GCF first. Here's what you're going to be tempted to do. You're going to be tempted to do that and leave it. Is that factored completely? No. It is not factored completely. Okay? We want things to be factored completely. Here you go. Let's do this one. 2x squared y minus 8y. Lee, what are we looking at? Two terms, so what do we do first? GCF. We want to look for GCF. What is the GCF? Not just y, 2y, right? Because 8's divisible by 2. So I can factor out a 2y, and what am I left with? X squared minus quattro. Now, when I'm factoring two terms, I have to go through my checklist. What's the next thing I have to check for? Did taking out a GCF result in a difference of squares? Yeah. It did, right? Because x squared minus 4, that's a difference of two things being squared. What does x squared minus 4 factor as? X plus 2 and x minus 2. So there's my complete factorization of that expression. Yes? Okay? Y'all all right? Next example. 2x squared plus, no, let's do minus there. Minus 19x plus 24. How many terms are we looking at? 3. So I'm going to look for a GCF, and then I'm going to try to unfoil it, right? Product of two binomials. Do we have a GCF? No, so what do we do? Trial and error, right? So I'm going to have, to try to get it to break down into two binomials, multiply times each other. And to bust up these middle terms, what do I do? Multiply 2 times 24, that gives us 48. Does positive 48 have any factors that add up to be negative 19? Yes. Yes, she says very definitively. The girl with the twin ponytails. Kinsey? Yes, sir. What are those two factors that we're looking for here? Negative 3 and negative 16 multiply to be negative 19, and they add to be negative 19, and they multiply to be positive 48. Now, that's that hidden factors, 3 and 16 is not the first factor pair we think of when we think of 48, is it? Everybody thinks of 4 and 12. Everybody thinks of 8 and 6. Most people get 2 and 24, but they leave out the 3 and 16. It's common in test banks. Very common to have to know that 48 is 16 times 3. All right? So these two middle terms, the middle term comes from negative 16x minus 3x. That's where we get our negative 19x from. All right? I don't have any choice for what goes first, do we? It's got to be 2x and x. You good with this, Kirk? So what will we multiply 2 by over here to give us one of those numbers? Negative 8. That gives us the negative 16, right? And then I need negative 3x to come from this times that, which means this has to be negative, not 3, negative 3. Okay? Now, as a final check, negative 3 times negative 8 is positive 24, negative 3x, negative 16x is negative 19x, and of course 2x times x is 2x squared. So that is a good factorization of that polynomial. Okay? All right. Three AX minus 24 plus 2BX minus 16B. Like this 24A. 3AX plus minus 24A. Like you're from Canada. A. What are we looking at?
4 more terms.
4 more terms. What are the properties of 4 more terms? What are we allowed to do to 4 terms here? Look for a GCF and then factor by grouping. You say graph.
I thought that's what. Okay, I copied that now.
Man,
So,
Dylan,
I thought it said graphing because it was a little
Dylan.
messed up. It said it. It's
All right.
on this board.
Do we have a GCF between all 3 terms? All 4 terms. Sorry. No. So I'm going to group them together like this and see what happens, right? What can we do with that first pair of terms as we've grouped them together? We can take out a 3A. That'll leave us with x minus 8. Yes. What can we take out of the second pair of terms? 2b or not? 2b, yes. That is the question. What play is that from?
Oh no,
That is from the Scarlet Ibis.
The Scarlet Ibis.
You read the Scarlet Letter. Hamlet?
Wrong.
Hamlet, yes.
Ibis.
isn't that about suicide?
Do what?
Read it.
Is that about what?
Isn't that quote about killing yourself? Like, to be or not to be? I think it was the
No,
suicide.
that was not in Hamlet. That was the on the flag of the snake. Remember the cut snake?
What?
Oh yeah.
No, that's don't tread on me.
No, it's not. It's to be or not to be.
Oh my god.
No, it's not, Dylan.
That's what it was.
No,
Don't tread on me.
Don't tread on me. It's the one with the snake. No, not. To be or not to be is from.
All right, let's get back to math. We have wandered into 4 different conversations here.
What history is it?
Here we go.
A lot of history.
Now listen. If when you factor out a GCF between your groups, if these 2 things are not the same, and you factored the GCF correctly, then the expression is not factorable. We wouldn't leave it like that and say that's the answer. Right? Okay, because I've not really helped myself by splitting it into 2 things that don't have anything in common. All right, but we do have something in common. Both of these expressions, both of these terms, this term and this term, have an x minus 8 in common. So I can take that x minus 8 out. And when I take the x minus 8 out, what is left over? 3a plus 2b.
flag.
That is.
It's too different. It is on the flag. Search the officer.
All right. Here we go. All right. Are y'all good with this? Let's look at another one. I think you're good. Shh. That's enough. Let's do 8x squared minus 2x minus 3. The instructions are to factor completely. Do we have a GCF? No GCF. Okay. So what's the process? I'm going to try to unfoil this. Trial and error. So I'll multiply 8 times negative 3. Looking for the factors of negative 24 that will add to be negative 2. What are they? Negative 6 and positive 4, right? So I don't know why that didn't, it went right over there. I can't get the 4 to form. I can't get the 4 to form. That's a 4. Okay? So these two things have to be negative 6x and positive 4x. So now I have a choice to make, right? The difference about this one is that 8x squared is a composite number, so I can't just go with 8x and x. I've got to determine if I'm going to use 8x and x or if I'm going to use 2x and 4x. 2x and 4x. Associate is correct. 2x and 4x is what we want to use because I can use those two numbers to get negative 6 and positive 4. Okay? Kirk, help me finish this. Two x multiplies by something over here. What am I going to try to get by that 2? So what do I multiply 2 by to get negative 6? Negative 3. Good. And then what do I multiply 4 by to get positive 4? 1. Plus 1. That's right. Well done. 1 times negative 3 is negative 3. 2x times 4x is 8x squared. That's a good factorization. No question that that's correct. Right? Because we multiplied it out and it works. Okay?